All right, in this set of notes, we're going to take a look at acceleration. And acceleration is the rate at which the velocity of an object changes with time. Symbolically, we see this in our reference tables. Acceleration equals change in velocity divided by time. If we're looking at acceleration as change in velocity over time, we have to look at the units of acceleration. So if the change in velocity is meters per second and the units for time is seconds, a meter per second is equivalent to meters per second squared. When we talk about accelerations in objects are always caused by forces. Because they're caused by forces and because an acceleration has to have some direction, acceleration is a vector value. That means there's some direction associated with that acceleration. You have to accelerate in one direction or another. When we cause an object to undergo acceleration, the velocity of the object upon which it acts will always change. So accelerations change the motion of an object, and forces are the causes of acceleration. When we talk about forces and acceleration, why things change what they're doing is because forces are placed on them, causing them to accelerate. Because they're a vector, we could always look at accelerations as being either positive or negative, depending on your coordinate system. If you have two vectors pointing in different directions, they can't share the same sign. So if you have something going to the right, something going to the left, one of them needs to be positive and one of them needs to be negative. Let's go over an example of acceleration. In this example, we have a car traveling at 7 meters per second, and it accelerates uniformly at 2.5 meters per second until it reaches a velocity of 12 meters per second. How long does it take this acceleration to occur? So we're going from 7 to 12 meters per second, so we're changing our velocity by 5 meters per second. We're going to determine how long, if it's accelerating at 2.5 meters per second squared, it takes that acceleration to change that velocity. Looking at our equation, acceleration is change in velocity divided by time. We can plug these values in, substituting in 2.5 meters per second squared for acceleration, and the change in velocity, 12 minus 7, which is 5 meters per second for our change in velocity, leaving us with one unknown in this equation, and that being time. And we find out that it takes 2 seconds for that acceleration to cause a change in velocity of 5 meters per second. There's a couple examples right now in your Nearpod. Go ahead and try those, and then we'll pick up and start looking at some motion graphs.